Welcome to basic thermodynamics class. So topic is chapter 2 thermodynamics process. So in this class we will discuss about the isothermal process and the numerical problem related to the isothermal process. Move to the next. So in the last class we discussed about the constant pressure process and some solve numerical problems on a constant pressure process. For constant pressure process, so the work done W is equal to integral PdV is changing from volume V1 to V2, putting the pressure as a constant. So we get the work done, amount of the work done is W is equal to P V2 minus V1, or we can write this equation as in terms of a MR T2 minus T1. So this is the work done. So work done is equal to P V2 minus V1 or MR T2 minus T1. So heat energy supplied Q is equal to mCp T2 minus T1. mCp T2 minus T1. And net flow energy equation, non-flow energy equation for the constant pressure process, U2 minus U1 is equal to Q minus W. So from this equation we get the U2 minus U1 is equal to mCv T2 minus T1, or can directly calculate by using the dq value and du value. Also we can get the du value. Du is nothing but the change in internal energy, and this equation, if it changes from one state to another state by keeping the temperature as a constant, so the equation of the state may be written as a V1 by T1 is equal to V2 by T2. So the constant pressure process is also called as an isobaric process. And the enthalpy during the constant process, the heat energy supplied is equal to change in enthalpy. So what is some heat energy supplied here? So the heat energy supplied is nothing but Q is equal to mCp T2 minus T1. So that is equal to the change in enthalpy. So dH is also equal to mCp T2 minus T1. T2 minus T1. So using these formulas solved some problems in the last class, and today also we discuss one problem before going to the today's topic. So today's topic is a isothermal process. Before going to that process, so one example problem we will discuss. Last class we discussed the three problems, the one more problem. A certain mass of gas expanding reversibly at constant pressure does 12 kilojoules of work. Calculate the quantity of heat supplied and change in internal energy. Assume gas is perfect and gamma value 1.66. So they given the gamma value and they asked to calculate the quantity of heat supplied. So Q and change in internal energy du. And they given the condition it is in a constant pressure. So I'm highlighting that what is the condition they given. So it is in a constant pressure. So the process is under the constant pressure or the isobaric process. So first you have to write the given data. So what is the given data? So the work done W is equal to 12 kilojoules, and we have to calculate the heat supplied. So heat supplied is equal to mCp T2 minus T1, and change in internal energy U2 minus U1 is equal to mCv T2 minus T1, and they didn't given any data. So how will you calculate? We don't know the Cp value and the Cv value, but they given only the gamma value. If they given the Cp value or Cv value, by using the relation Cp minus Cv is equal to gamma, we will find another value. But in the problem, they given only one value, that is an adiabatic index gamma 1.66. So they didn't give another uh, other than the gamma value. So how will you calculate? So first write the given data. First I am writing the given data. So the work done. So W is equal to 12 kilo joules. W is equal to 12 kilojoules. After that, they didn't give any data. They asked to calculate the heat supplied. Heat supplied at constant pressure Q is equal to mCp T2 minus T1. mCp at constant pressure, the heat supplied Q is equal to mCp T2 minus T1. Cp is a specific heat at a constant pressure. T2 and T1 are the initial temperature and the final temperature. Now they'll ask again the question, change in internal energy. So change in internal energy means U2 minus U1 is equal to mCv T2 minus T1. So you know these two formulas. So they asked to calculate the Q value and E value, but you don't know the Cp value and the Cv value. You know, and you don't know the temperatures also. You know only the this one. What is this? Work done and the gamma value. Then how can you calculate? So according to the non-flow energy equation, you know that du is equal du is equal to dq minus dw, or w is equal to q minus u2 minus u1. According to the non-flow energy equation, w is equal to q minus u2 minus u1. So substitute the q value, and u2 minus u1 value in this equation. So how it is it? You know that w is equal to, what is the q value? Q is mCp T2 minus T1. So substitute the q value here, and u2 minus u1 value mCv T2 minus T1. So here in the both, the what is the common here? What is the common here? M T2 minus T1. So what are the remaining terms here? Cp and Cv. If you take the common m T2 minus T1, and the remaining terms are Cp minus Cv. So the equation will comes m into T2 minus T1 as a common. In this term Cp, in this one Cv. So m T2 minus T1 minus into Cp minus Cv. So this problem is very important for the 5 marks question. In this question, they didn't give any data other than the work done and adiabatic index. Then how do you calculate? So simply whatever they ask, the heat supplied, you know the heat supplied formula as a Q is equal to mCp T2 minus T1, and the U2 minus U1 is equal to mCv T2 minus T1. So simply substitute in the non-flow energy equation, you will get the W m T2 minus T1 into Cp minus Cv. So Cp minus Cv we can write as a R, but we don't know the T2 minus T1 values also. That's why I'm converting. You Cp minus Cv is equal to R, but they didn't given that the R value. They given only gamma value. So how will you write the Cp minus Cv? Means I'm taking Cv as a common. Cv as a I'm taking Cv as a common. So m T2 minus T1 Cv. So it becomes Cp divided by Cv minus 1. So just go on multiply, bring this Cv into bracket side, will come Cv in numerator, Cv in denominator, get cancelled, Cv into 1, Cv. So Cp minus Cv. Just I am bringing this Cv to the outside, then it becomes Cp by Cv minus 1. So we all know that the Cp by Cv is equal to gamma. We all know that Cp by Cv is equal to gamma. So here I am substituting Cp by Cv as a gamma value. Cp by Cv as a gamma value, adiabatic index. Adiabatic index. So this mCv T2 minus Tv also I am writing as a internal energy. Internal energy. Internal energy U2 minus U1. U2 minus U1. In the next step I am writing. Here in this I am converting the Cp by Cv as a gamma, and mCv T2 minus T1 as a change in internal energy. Change in internal energy. So you want to calculate the change in internal energy. So put this change in internal energy this side and bring this gamma minus 1 into left hand side. So it will come into divided by. Divided means W value, how much they given? 12. Gamma value 1.66 minus 1. So U2 minus U1 is equal to W gamma minus 1. It comes as a 12 divided by 1.66 minus 1. The answer is 18.18 kilojoules. So without data also, by mathematically doing the expressions, we can find the value of a change in internal energy. So change in internal energy. So according to the first law of thermodynamics, dq is equal to du plus dw. So W value they given in the problem, and U2 minus U1 we calculate in the first step. So W12 U2 minus U1 is a 18.18. So total 30.18 kilojoules. 30.18 kilojoules. So the quantity of the heat supplied is 30.18 kilojoules, and the internal energy is 18.18. So in this problem, this is a problem is very important. They given only two values, W and gamma. So how will you calculate? Means first write the given data. So W is equal to 12 kilojoules, and next they given the heat supplied. You have to calculate the heat supplied and change in internal energy. So heat supplied dq is equal to mcp T2 minus T1. mcp T2 minus T1. We know that. Next internal energy mcv T2 minus T1. So put it in first law of thermodynamics for the non-flow energy equation. W is equal to Q minus U2 minus U1. It becomes mcp T2 minus T1 bracket closed minus mcv T2 minus T1. Here m into T2 minus T1 is a common. So the remaining terms are the Cp and Cv. So I am writing the Cp minus Cv also, we can write R. But in the problem they didn't mention the R value. They mention in the gamma value. When the gamma will come, the ratio of a two specific heats Cp by Cv is equal to gamma. That's why I am taking Cv as a common and bring outside. It becomes m T2 minus Tv Cv gamma divided by gamma minus 1. So here also we can write, clearly observe that mcv T2 minus T1. So we can write it as a change in internal energy. So work done they given them, and gamma they given. So change in internal energy, how will you get? So W12 divided by 1.66 minus 1, 18.18 kilojoules. So dq is equal to du plus U2 minus U1. So what is the W value? 12. U2 minus U1. In the first problem we got 18.18. So total 30.18 kilojoules. So this is a problem related to constant pressure process. So today's main, so on the completion of this period you would able to know that what is hyperbolic process, constant pressure temperature process. Constant temperature process is same as hyperbolic process, and the expression for the work done in constant pressure process. In the next class, we will discuss the problems related to the isothermal process. So first, what is a hyperbolic process? So hyperbolic, and this constant temperature process is also called as an isothermal process. So first coming to the, we are learn about the hyperbolic process. So what is the hyperbolic process? A process in which the gas is heated or expanded in such a way that the product of pressure and volume remains constant is called hyperbolic process. So this process is based on the Boyle's law. So here we are keeping the temperature as a constant. So either we give the heat to the system or heated or expanded in such a way that the product PV must be constant for every process. For each process, the product PV is equal to constant. But the pressure increases, volume is decreases. If volume increases, pressure decreases. This is known as hyperbolic process. So hyperbolic process is governed by the Boyle's law. So what the Boyle's law states it, at the constant temperature, the pressure of the gas is inversely proportional to the volume of the gas occupied. So P is inversely proportional to V. Can write this as a PV is equal to constant. Next. So if you plot the graph between the pressure and volume during the process, we shall get the rectangular hyperbola. That's why we call it as a hyperbolic process. See that if you draw the pressure as the, here we are increasing the pressure and volume are inversely proportional as the volume is increases, as the volume is increases or volume is decreases. In this case the volume is decreasing, in this case the volume is decreasing and the pressure is increasing. So pressure is increasing, volume is decreasing. This is a hyperbolic process, but PV is equal to constant. So whatever the work is done is between the point A to point B. So we plot the graph between pressure and the volume during the process and we obtain the shape of the rectangular hyperbola. So this process is also called as a hyperbolic process. Next, so hence the process is named as a hyperbolic process. So it is a merely theoretical case. Its a practical application is constant temperature or isothermal process. So I called as an isothermal process also. An isothermal process is the one which takes place at constant pressure. Here the constant temperature. Here we have to put the temperature as a constant, means dT is equal to 0. So this is a possible if expansion or the compression takes place very slowly. So the heat exchange will takes place have a sufficient time to allow the temperature to remain. So a process in which the temperature remains constant during the expansion or compression. So process in which isothermal means, iso means same, thermal means temperature, same temperature. A process in which the temperature of gas remains constant during the expansion or compression is defined as an isothermal process. So the heat exchange will take place having then a sufficient time to allow the temperature to remain constant to temperature. So this is possible if expansion and compression takes place very slowly. So when it will happen, the temperature is constant. So only the expansion or the compression takes place slowly. So constant pressure process occurs when the system is in a contact with a constant temperature, that is a reservoir or a source. So what is isothermal process means? A process in which the temperature of a gas remains constant during expansion or compression. This is possible where it is possible. So how can you say? So the expansion and the compression takes place very slowly. So if you take the piston and cylinder, if you take piston and if you take the cylinder and a piston, if you the piston moves from TDC to BDC and BDC to TDC, then expansion, first the compression, next expansion. So the process will slowly takes place, then the isothermal process is takes place. So this illustrated by a gas contained in a cylinder and a piston with a constant temperature reservoir as shown in. Here we are maintaining the constant temperature. So we are maintaining constant temperature. This is nothing related to the Boyle's law. Here we are goes on increasing the pressure. If we are increasing the pressure, the volume is coming down. So volume is coming down means compressed. Volume is compressed. If pressure is decreasing, the volume is expanding. The piston is expanding. So the pressure is inversely proportional to the volume. As the pressure is increasing, the volume is decreasing. As the pressure is increasing, volume is decreasing, or vice versa. If the pressure decreases, volume decreases. And the product of the P and V should be constant for the each and every process. So at the first process, at the second, third, fourth, five, sixth, the process PV must be constant. PV must be constant. But P1 V1 and P2 V2 are the different. But P1 V1 is equal to P2 V2. The product of all the pressure and the volume should be constant. So if the pressure is increasing, the volume is decreasing. If the volume is increasing, pressure decreases. So this is nothing but the Boyle's law. If the heat is supplied to the system from the surroundings, then equal amount of work is given out by the expansion of system. So if we are giving the heat to the system and some certain amount of the work is given out by the expansion of the system. So heat supplied. So we are giving heat to the system, and some amount of the work is coming out from the system, coming out is giving out by a expansion. So by expanding the by expansion means the volume is increasing. If you are heating the system, that the volume of the container is increasing. If the heat is rejected, if you remove the heat, then if you remove the heat from the system, means that the volume is goes on decreasing, is done by the system. It's a decreasing means we can tell that cylinder is compression. The first one is expanding, the volume is increasing means expanding. Second case, volume is compressing means compression. So where the process is occurred, if you are giving the heat, if you are giving the heat supplied means giving the heat means the work is given out by the expansion of the system. If the heat is rejected, some heat is rejected means we are removing some heat from the system. So the amount of the work done is the system by compression. So first one, the amount of the work done by the expansion, and in the second case the amount of the work is done by the compression, work is done by the compression. So next, move to the next slide. As the heat energy is supplied, the gas will expand from state 1 to state 2 at constant temperature. So we know the general gas equation, P1 by P1 V1 by T1 is equal to P2 V2 by T2. So we know the general equation. Here we are telling that T1 equal to T2. According to the Boyle's law, temperature is remains constant. So T1 is equal to T2 means get the cancel. T1 equal to T2. T1 is equal to T2 mean they will get cancelled, and the P1 V1, if T1 equal to T2 is equal to, then the remaining term is P1 V1 is equal to P2 V2. P2. So if the gas is heated at constant pressure, T1 equal to T2. So for the above equation comes like a P1 V1 is equal to P2 V2, or we can write as a PV is equal to constant. So from the above equation it is inferred that the hyperbolic and isothermal process are the same for the gases. From the above equation it is inferred that the hyperbolic and isothermal process are same for the gases. So here they consider what they consider for the constant temperature process, the equation of the state is reduced to the following form. Now what is the following form? We know the gas equation P1 V1 by T1 is equal to P2 V2 by T2. Here the constant temperatures means T1 equal to T2. Then it becomes P1 V1 is equal to P2 V2. We can write this equation as a P1 by P2 is equal to V2 by V1. So according to the Boyle's law, P is inversely proportional to the temperature. So PV is equal to constant. So since the temperature difference dT is equal to 0, the change in internal energy is equal to 0, and the change in enthalpy is also equal to 0, because this all the terms are depends upon the temperature only. If the temperature is 0, the change in internal energy is equal to 0, and the change in enthalpy also equal to 0. From the above expression, work done by the gas during the expansion. So this is the graph, PV graph. So whatever the work done, the area is in the shape of a hyperbolic process. So that's why we call it as a hyperbolic process. So if you are giving the heat to the system, if you are giving the heat to the system, here the system of the gas is expanded. Here the system of the gas is expanded, and the volume is increases, pressure decreases. If you remove the heat from the system, the volume decreases and the pressure increases. So here the pressure is inversely proportional to the volume. Pressure increases, volume decreases, volume increases, pressure decreases. So this is the graph representation. This is a curve. So that's why it is the area under the curve is in the rectangular hyperbolic shape. So that's why it is called as a rectangular hyperbolic process, or a isothermal process, or constant temperature process. So consider 1 kg of gas changes from state 1 to state 2 at constant temperature T. So here I am considering the 1 kg of gas changes from state 1 to state 2. Here the temperature is remaining constant. Temperature is remaining constant. Consider a small change in volume at a pressure. So dV. If you consider the change in volume as a dV at pressure P, the work done during this small change in volume is P dV. So work done during the small change in volume. Here the small amount of the volume is changed at pressure P. So how will you get that work done during the small change in volume? dW is equal to P dV. dW is equal to P dV. On integrating that, we will get work done is equal to integral P dV. So this is the expansion of the gas is isothermal, PV is equal to constant. P1 V1 P is equal to, I am writing this equation, PV is equal to P1 V1 is equal to P2 V2. So P divided by P is equal to, I am writing this equation as P is equal to P1 V1 divided by capital V. So we know the values of a PV and we can find the volume or anything. So PV is equal to P1 V1 is equal to P2 V2. So move to the next slide. So I am writing the P is equal to P1 V1 divided by V is equal to P2 V2 by V. So therefore, will you write the work done 1 to P1 V1 divided by V into dV. So I am writing this P. Here we can quote the P as a P is equal to P1 V1 by V. PV is equal to this one. So simply I'm substituting here as a P in place of a P. I'm writing this a P is equal to P1 V1 divided by V into P dV. Here the I'm bringing P1 V1 as a outside and 1 by V as a variable. So P1 V1 integral V1 V2 1 by V dV. So integration of 1 by x dx is nothing but the log x. Integration of 1 by x dx is log x. Here what is the term? V. So integration of 1 by V dV. 1 by V dV. So integration 1 by V is equal to log V. Log V is nothing but I am writing applying the upper limit and the lower limit. So log V V2 minus log V1. So we know that log m minus log m we can write as a log m by n. So P1 V1 by log V2 by V1. P1 V1 log V2 by V1. So these we can write as a P1 V1 is equal to log E P1 by P2 because so Boyle's law. What is the Boyle's law tells that the P is directly proportional to P is directly proportional to 1 by V. P is directly proportional to 1 by V. So I am writing this V2 by V1 as a V2 by V1 is equal to P1 by P2. P1 by P1 by P2. P1 by P2. So work done during the isothermal process is P1 V1 log E V2 by V1 or P1 V1 log E P1 by P2. So here I am considering the mass of a mass m in terms of a kg. So changes from initial state V1 to final state V2 at a constant temperature. So you don't have any derivation, just we have to remember the formulas only, but I am telling how the formulas will get. Simply learn. In your syllabus there is no derivations, but we have to learn how will you get this formula. How will you get this formula? So work done is equal to, so work done is equal to, what is the work done? P1 V1 log V2 by V1 is equal to P1 V1 log P1 by P2. So here that the, how will you get that in isothermal process, heat is supplied to the system from the surroundings must be equal to the work delivered to the surrounding. So according to the non-flow energy equation for the isothermal process, we am writing as a dq is equal to du plus dw, but the internal energy du is a 0, because here we are taking this a constant temperature. So constant temperature means the change in internal energy is equal to 0 and the change in enthalpy is also 0. So what is the remaining here? If the internal energy is 0, so q is equal to w. So the path of the process, the PV diagram you see in the will appear as a rectangular hyperbola, and hence the isothermal process is referred as a rectangular hyperbolic process. So we know that PV is equal to P1 V1 is equal to P2 V2. So from that I am writing that the P is equal to P1 V1 by V. So I am writing here, we know that the work done integral P dV. So in the place of a P I am writing P1 V1 divided by V dV. So where P1 and V1 are the constant, I am bringing them outside the integral, and the remaining is 1 by V dV. So integration of 1 by V means log V, and there are the two limits, upper limit and lower limit. So substitute the limit values. So upper limit minus lower limit, it becomes P1 V1 is equal to log V2 minus log V1. All we know that log M minus log N is equal to log M by N. Log M by N. So like that I am write the P1 V1 log V2 by V1. So we know that the P is inversely proportional to the volume. So P1, if P is inversely proportional to the volume, means V2 by V1 is equal to P1 by P2. So I am writing this equation as a P1 V1 log P1 by P2, and this equation also we can write in terms of a temperatures. So we all know that PV is equal to MR T2 minus T1. PV is equal to MR T2 minus T1. So I'm writing this as in terms of a PV, I'm writing as a MRT log E V2 by V1 or MRT log P1 by P2, where the temperature T1, T2 is equal to 1. And here the V2 minus V1 is also called as the expansion ratio and denoted by R. So V2 by V1 is the expansion ratio and we are denoted by the R. So the work transferred during the isothermal process is given by MRT log ER. So I am writing this V2 by V1 as a expansion ratio. So what is the expansion ratio? Means the ratio between the final volume by the in final state 2 to the initial state 1 is called the expansion ratio, and it is denoted by the R. So W is equal to MRT log V2 by V1, MRT log P1 by P2. So here I am writing V2 by V1 as a R. So it becomes P1 V1 log ER or MRT1 log ER. So the compression ratio is also there. In the compression ratio it is decreasing, means the compression ratio is V1 by V2. We will get the case of compression ratio, R is referred as a compression ratio. R is equal to V1 by V2. In the expansion ratio, it is V2 by V1. In compression ratio, the volume is compressing. It means the negative value, V1 by V2. So work done during the compression. So P1 V1 log E V1 by V2 or P1 V1 log E P2 by P1. If you write the V1 by V2 here, then automatically it is inversely proportional to the pressure. So it is P2 by P1. So during the isothermal expansion of gases, during the isothermal expansion of the gases, W is positive and the Q must be also in a position that heat energy must be supplied to the gas during the expansion, so that the temperature of the gas is maintained constant, maintained constant. Similarly, in isothermal compression, is a W is negative and the Q must be also in negative. Then the heat energy must be rejected and heat must be rejected from the gas during the compression to maintain the constant temperature. Means that the isothermal process is a constant internal energy process. So, we will calculate the change in internal energy process, change in internal energy process. So, we know that the change in internal energy U2 minus U1 is equal to mCV T2 minus T1. You know that? We know that the change in internal energy U2 minus U1 is equal to mCV T2 minus T1. So, since at constant temperature T2 minus T1 is equal to 0. So, internal energy is 0. So, U2 is equal to U1. So, the internal energy remains constant in isothermal process. So, in isothermal process, the internal energy should be constant. So, what does happen here? During the isothermal expansion of the gas, here the W is positive. W is positive means the Q must always in a position that heat is supplying to the system. Heat is supplying the system is the gas. So, the volume occupied by the gas is expanding. Expanding, the volume is increasing. The gas during the expansion, so that the temperature of the gas is maintained the constant and the temperature of the gas should be always constant. Similarly, for isothermal compression, W is negative, the Q must also be negative. The Q must also be negative. That is, the heat energy must be rejected from the gas during the compression to maintain constant temperature. So, constant temperature. So, from these two, we know that the change in internal energy is mCV T2 minus T1. Here the temperatures are constant. T2 is equal to T1. So, U2 minus U1 is equal to mCV T2 minus T1. So, both are equal means T1 minus T is 0. So, here the U2 is equal to U1. So, the internal energy remains constant in isothermal process. In isothermal process. So, what will you learn in this class means about the isothermal process. So, what is isothermal? First, hyperbolic process. Next, constant temperature or isothermal process. So, hyperbolic process. In this process, the product of the pressure and the volume remains constant. So, according to the Boyle's law, the temperature remains constant. So, as the pressure is increasing, the volume is decreasing, but the product P into V always remains constant. The next, the constant temperature or isothermal process. So, another name of the constant temperature is isothermal process because iso means same, thermal means temperature. So, same temperature, maintaining the same temperature we call as a constant temperature or isothermal process. So, in this process, we are maintaining the temperature is constant throughout the process. Throughout the process. For the gases, isothermal and hyperbolic process are the same and governed by the Boyle's law. So, what the Boyle's law is telling there? As the pressure is goes on increasing, the volume is decreasing. But then the product should be same. But the product P into V is equal to constant. P into for the each state. If it is changing from state 1 to the state 2, so at state 1 we will calculate the P1 V1. Their product P1 V1 is equal, they will get one value. Suppose we get 30 kilojoules. And then the state 2 also, the product of the P2 V2, we will get the same 30 kilojoules. So that states that the Boyle's law. Maintaining the temperature at constant, the pressure is inversely proportional to the volume. That is nothing but the PV is equal to constant. PV is equal to constant. If you draw the graph, as the pressure is increasing, the volume is decreasing. As the pressure is increasing, if you take the pressure in a x-axis, y and v in y-axis, the pressure is goes on increasing, the curve goes on decreasing, the volume goes on decreases. So this is also known as a rectangular hyperbolic process. Rectangular hyperbolic process, isothermal process. So work done for isothermal process. So work done, how will you calculate the work done? So work done, the at temperature constant means P1 V1 is equal to P2 V2. So P2 by P1 is equal to V1 by V2. So dt is equal to 0 means the change in internal energy is equal to 0 and change in enthalpy is also 0. So here the work done, if you consider the mass m of a gas changes from a initial state 1 to final state 2 at constant pressure, the work done P1 V1 is the work done, W is equal to P1 V1 log V2 by V1. So I am writing this V2 by V1 as a P1 by P2. So we can write this equation in terms of a pressure also, P1 V1 log P1 by P2, or otherwise in terms of a characteristic gas equation also we can write. So work done is equal to MRT log E V2 by V1, or log or MRT log E P1 by P2. Here the temperature T1 equal to T2 equal to T. So, and there also we can write, we are taking this a V2 by V1 as a expansion ratio and designed by the R. So then the work transfer during the isothermal process I am writing as a P1 V1 log ER MRT, or PV is equal to MRT. So I am writing as a T is equal to T1 equal to T2. So we can write this as a MRT1 log ER here, but T1 equal to T2 equal to T. So we can write this as a MRT log ER. In case of expansion ratio, R is equal to V1 by V2. So we can write as a P1 V1. Here the work done during the compression, P1 V1 log V1 by V2, or MRT log P2 by P1. And we know that in isothermal process the change in internal energy is 0 because dt is equal to 0. dt means T1 equal to T2 equal to T. So we know that the change in internal energy du is equal to mCV dt. So dt T1 equal to T2 is equal to 0 means automatically internal energy is 0 and change in enthalpy also 0 because the temperature is constant. So T1 equal to T2, T1 is equal to T2. So in terms of the compression ratio also, W is equal to P1 V1 log V1 by V2 is equal to MRT log P2 by P1. So in isothermal process the work done is equal, so in the constant temperature process, the isothermal process, the constant internal energy is a 0. Internal energy is a 0 in the isothermal process. So internal energy is a constant. So in the next class we will solve some numerical problems based on the constant temperature process. So for the constant temperature process, you know that basically three formulas, the expression for the work done formulas. The work done formulas are two formulas, P1 V1 log V2 by V1, or in terms of a pressure is P1 V1 log P1 by P2, or work done is equal to MRT log V2 by V1 or MRT log P1 by P2. And we have to remember the expansion ratio is V2 by V1, or the compression ratio is opposite to the expansion ratio. So R is equal to V1 by V2, V1 by V2. So in the next class we will solve the problems of the based on the constant temperature process, and after that we will discuss about the adiabatic process. So adiabatic process means no heat energy is transferred to or from the system is called an adiabatic process. Just I'm giving the definition only. In the mostly tomorrow's class we will discuss some problems related to the constant temperature or the isothermal process. So if the time permits we will discuss about the adiabatic process also. So see you in the next class.